Hello there, Year 9 and 10. Welcome back to the online lesson 10 from St Leonard's Academy Science Department in Physics. This lesson, we're not going to introduce any new content. We are just going to revise all of the topics that we've touched on this since we've started doing the online lessons. This is in preparation for the exit task this week, which will be a mock paper 1. Don't worry, I've picked what I think should be relatively straightforward questions, so you should all be able to do some of the paper. It does step up a little bit towards the end, but I think you should all be able to attempt much, if not all, of the paper, even if you're foundation or higher. It will take, I estimate the revision lesson will take much less than an hour, and the equipment that you'll need will be a pen, paper. Ideally, if you've got A3 paper, that would be fantastic this week. If you don't worry, but A3 paper would be the best. And if ideally you've got a quiet, clear workspace. If you don't have any of those things, I'd like you to pause the video and try and get them now. Okay, let's move on. So just a quick reminder, as always, the work expectations from St Leonard's Academy Science Department over COVID lockdown. You've seen it so many times, I don't need to go through it all, but I'll say it again very, very quickly. We'd like you to try to complete 3 hours of science work per week, and that can be the revision booklets that we've given you, it can be online lessons like this, or it can be your own work, for example, revision using BBC Bitesize or Oak National Academy. Okay, so just a heads up to show you all of the things that we've touched on this term, and one that we didn't touch on, but I will rely on you guys to look at yourselves or wait until next year. So in Combined Physics Paper 1, these are all of the different topics you can be examined on. We've got key skills, CP1 Motion, CP2 Forces and Motion, CP3 Energy, CP4 Waves, CP5 Electromagnetic Waves, and CP6 Radioactivity. If you look back in the online lessons, you'll see that we've got 1 or 2 lessons on every single one of these topics. Unfortunately, we've run out of time for the triples. We didn't get time to do SP7, which is astronomy. That would also be, if you're a triple award science student or single physics student, you would also have SP7 astronomy on your paper 1. Just something to bear in mind. I haven't included it on the mock that we are doing this year, this lesson. Okay, let's get started. Our LQ is a bit silly this week. If you'd like, you can include in your answer, if anyone knows where that quote is from, who the quote is from, then do please include it in your Showbie answer. You can get extra £5, possibly a prize, who knows. For our Do It Now, what I'd like you to do on ideally an A3 sheet of paper is to write Physics Paper 1 in the middle of your page, like this. And all around the outside, do it as neatly as you can, because the whole of this lesson, we are just going to be adding to our mind map. Okay, so around the Physics Paper 1 in the middle, I'd like you to write down these all of our topics that may come up in the mock and in paper 1 and in our mock. So we've got our motion, movement, forces, energy, waves, electromagnetic waves, radioactivity, astronomy. If you're a triple student, you can include that one, and key skills. I'd then like you to add anything that you can remember from these topics from all of our online lessons. Even if it seems stupid or like it's not relevant or whatever, I just want you to write down everything that you can about these different topics. Okay, and don't worry if it's not that much, if you can't think of very much, because I will be going through with some prompts during the lesson, during this revision lesson. Okay, you can pause the video and do that now. Okay, let's move on. Yeah, so we're not gonna do any questions in this or problems this lesson, this revision lesson. I'm going to give you prompts, things to jog your memory for each of these topics, precisely on the parts of the topic that we dealt with during the online lessons, so that you can include them for your revision and you can add them to your mind map so that you focus your revision down on exactly the things which are important. Okay, so key skills. These are the things that you should have around your key skills bubble. You could include these as an offshoot of the key skills. You've got units. What is a unit and why do we need them? SI units. What are the SI base units? There are 7 of them. And what are the SI derived units? You might get a little clue for the base units up here in the top right. Standard form. How do I write a number in standard form? Remember, standard form is that thing which is a number between 1 and 10 multiplied by 10 to the power of something. Unit prefixes: kilometers, millimeters, centimeters, nanometers, etc. What does kilo, nano, pico, micro mean for unit prefixes? And then converting units. So, for example, from 1,000 meters is equal to 1 kilometer. Now, I'm not going to go through these because if you don't know the answer to any of these questions or you need more information, you can simply go to the 2 key skills lessons that we've done before. Okay, so if you want to swat up on these before the mock and you don't know the answers, then go to I think it's lesson it's lesson 3 and 4, online lesson 3 and 4, which are 2 full lessons on key skills. You can find the answers to these. You can also check out the link below the lesson for a link to the BBC bite-sized topics on key skills to help you get something down for all of these points if you don't know them already. Okay, then motion. If you didn't get this, you can add these to your mind map. Scalar versus vector quantities. A little hint up here to the right. What might be the difference between a scalar quantity and a vector quantity, and some examples of scalar quantities versus vector quantities. Remember, a scalar quantity has a magnitude, a vector quantity has a magnitude and a direction. So, for example, distance, if I say I've traveled 10 meters, that's a distance. If I say I've traveled 10 meters west, that is a displacement. Okay, 10 meters, that's the magnitude, west is the direction. Circular motion, something to swat up on. You can go back to the first online lesson with Miss Page and your answers you submitted for it. In circular motion, something, for example, orbiting the Earth, we could say it's traveling at a constant speed, but it's changing its velocity all the time. How is that the case? And finally, something else for motion. I don't think Miss Page dealt with this in her lesson, but it's something that you should know anyway. Speed, the equation for speed, distance, and time. Speed is equal to distance divided by time. Speed equals distance over time. So that all of these things might come up on the mock, and those are the things that I want you to include on your mind map. And if you don't understand any of them at all, then go back to that lesson 1 or look at the link below the YouTube video. Okay, forces then. We should have another arrow pointing up, and then we have a resultant forces 0, car stays at constant velocity. So CP2 forces, the only things that we dealt with, we had that 1 lesson on forces, so these are the only things that can come up on forces on the mock that I'm going to set. It is Newton's 3 laws of motion. What are Newton's 3 laws of motion? You've got some hints here the first, second, and third. But of course, that doesn't explain the laws and how they work. So you can write down from forces, you can write Newton's 3 laws of motion, first, second, and third. But then if you'd like to include more detail, you can write what you can remember about the first, second, and third law. You can also go back to the online lesson on forces, which was, if memory serves, lesson 5, I think. Or check out the link below the YouTube. So what were Newton's laws? Just to quickly go through them. Newton's first law, an object remains in the same state of motion unless a resultant force acts on it. So that could be either moving at a constant speed or stationary. If all of the forces on an object are balanced, then there is no resultant force, and the object will continue doing whatever it's doing, either stationary, not moving, or moving at a constant speed. If in any direction, then the object will accelerate in that direction. So in the example of our car, if it had these 3 forces acting on it, force acting forwards, a force acting backwards, and a force. If we added these forces together, these 2 forces would cancel out, we would still have a force acting down, and the car would start to accelerate downwards into the ground. Second, how could we calculate the size of the acceleration of the car due to having a force? Newton's second law, Newton said the resultant force acting on an object is equal to the object's mass multiplied by the acceleration of that object. So if I know the car's mass and I know the force acting on it, then I can calculate the acceleration of the car. And then Newton's third law, every action has an equal and opposite reaction. If I push on my hand, then my hand pushes back. If I push on the desk, then the desk pushes back. If I sit on my chair, my weight is acting down on the chair. The chair is acting back up on me. If that wasn't the case, if my weight was just acting downwards and there wasn't a reaction force, then I would fall downwards through the chair. So every action has an equal and opposite reaction. Again, if any of this is not clear, then go back to the online lesson with forces, or check out the link below the YouTube. CP3 Energy, some ideas for your mind map. What are the 8 energy stores? And what are the 4 energy pathways? What is an energy store and what is an energy pathway? Remember, energy store is somewhere where we can store energy for a long time, and a pathway is one of the ways, is a way in which we can transfer energy from one store to another. What was that law of conservation of energy? Energy, also known as the first law of thermodynamics, could be something along the lines of energy cannot be created or destroyed, only conserved, only changed form. Sorry, I've garbled that. Energy cannot be created nor destroyed. It can only be changed in form. That's a bit better. What is useful versus wasted output for any transfer of energy? And what do we mean by efficiency? What's the equation for efficiency? And how do you use it? Some examples of energy stores. Okay, CP4 waves. What is a wave? We had those 3 things on the lesson from waves. So what is a wave? What does a wave do? Transfers energy, not mass. What are the types of wave? So for example, sound wave, water wave, electromagnetic wave, and so on. And what is a transverse versus a longitudinal wave? Remember, this is to do with the particle motion of the wave. Here we've got an example of a transverse wave in a slinky and a longitudinal wave in a slinky. In a transverse wave, the vibration of the particles, or the vibration of the slinky, is at right angles to the direction that the wave moves. In a longitudinal wave, the vibration of the wave of the slinky is parallel to the direction of the wave. Okay, let's move on. To add to your mind map, if you're the part on electromagnetic waves, things which you should have down and which you need to find out if you don't have down. What is an electromagnetic wave? It's a oscillation in the background electric and magnetic fields. Travels at the speed of light in a vacuum, 3 times 10 to the 8, and has associated with it a wavelength, a frequency. A wavelength and a frequency. What do we mean by wavelength and frequency? Whoop, don't want to go back there. What do these two words mean? Find a definition for wavelength and frequency. And you could also find the unit for wavelength and frequency. And what is the electromagnetic spectrum? You've got a model, a depiction of the electromagnetic spectrum here. Remember, we need to know all the different parts of the spectrum, from radio, microwave, infrared, visible, ultraviolet, X-rays to gamma rays. What are they ordered by? So they're all the different electromagnetic waves that exist in nature, ordered by wavelength. So wavelength decreases from radio to gamma. They're also ordered by frequency, but frequency decreases. Frequency increases from radio waves to gamma rays. So radio waves have the lowest frequency of any of the waves, and gamma rays have the highest frequency. On the picture here, you've got some examples of things which create the different parts of the electromagnetic spectrum. So a radio, a microwave, a TV remote, a light bulb, the sun, the X-rays and gamma rays are created by radioactive elements, unstable radioactive elements, and also X-ray machines for X-rays. Okay, here's a depiction or a model of an electromagnetic wave to the top right. We've got it's an oscillation or a vibration in the electric and magnetic fields. And that oscillation is at right angles to the direction of wave motion. So they are transverse waves. And if you're struggling to remember the order of the electromagnetic spectrum, don't forget, you can use a mnemonic, you can make up your own, or you can use mine. Rebel monkeys in velvet underpants excrete gummy bears. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, and gamma rays, gummy bears. That's just to show that our spectrum is in order of wavelength. And lastly, we have radioactivity. And to your mind map for radioactivity are atomic structure. What is and what do we mean by atomic structure? What are the atomic particles, the subatomic particles? Protons, neutrons, electrons. What are their charges and what are their masses and where are they in the atom? So you need to know that electrons orbit the nucleus of an atom and they orbit in fixed shells. These are electron shells. The protons and neutrons of an atom sit in a small, dense nucleus. It's where 99.99% of the mass of the atom is in the nucleus, because protons and neutrons are relatively very massive compared to electrons. That's what we mean by atomic structure and the model that we need to use for GCSE level. You also need to know a little something about atomic models through time. So what were the 4 models that we studied in our lesson, I think it was lesson 2. What were the 4 models that we mentioned? Ones to have at your fingertips, to include in your mind map are Dalton's indivisible balls. We've got then we've got J.J. Thomson with his plum pudding. Then we've got Rutherford with the Rutherford nuclear model. And finally, we have Bohr with the Bohr's planetary model. Okay, so those are the 4 models that we need to know of. If you could draw sketches of those around your mind map, that would be fantastic, and with the key features of each. What do we mean by AZ notation? It's a way for us to write an atomic structure of an element or an isotope. So what do we mean by it? And then what is an isotope? Now remember, if you don't know the answer to any of these, you don't know any of the definitions of what these are, then check out the link below the YouTube and check out the other lesson, the online lessons that we did on radioactivity, which was, I think, lesson 2 and lesson 5. Also, I'll include a link for BBC Bitesize for you to check these out. And if you are not a triple student, then you don't have to worry about this. But if you are a triple student, we didn't get time to do astronomy, an online lesson on astronomy. Things for you to, and it's not going to be in the mock, which I'm going to share with you in just 1 second. But things, the types of things you would need to know for astronomy, which you may like to revise in your spare time or go over in your spare time between now and September, are the force of gravity on different planets. You will need to know the contents of the solar system, the planets, the asteroids, the satellites, the moons, etc. The order of the planets in the solar system, you might well come up with a mnemonic for that. You'll need to explain what redshifting is, and you need to explain the Big Bang and the steady state theory. I'll put a link to all of this below the YouTube, don't worry. Okay, that's it. Before you get started on the mock, you can go back over this revision lesson and continue to add stuff to your mind map. Make it a really great mind map, including all of the different parts of the topics that we've dealt with during this revision lesson. Make sure to include all of those and to have 1 or 2 sentences to write about each one. If you're stuck on any of them, check out the links below the PowerPoint. Okay, if you've got a beautiful mind map, you've revised extremely effectively and efficiently, then you're ready. I've produced a special mock for us. It's only 40 marks, 40 marks, so it should take you about 40 minutes to do. And it includes questions touching on content from every online lesson that we've done this term. Okay, so if you would like to go to shobi.com and log in using the class code HZ9N9, download the mock physics paper 1. You can see I've shared it with the class. You can download it either as a Word or as a PDF document. Now, you can work on that however you prefer. You can either work directly on the downloaded Word document, and actually on your computer write in the answers. You can also, if you download it as a PDF, you can print it out on paper and then complete it by hand. Or if you don't have access to a printer or a word processor, you can display it on a screen and just answer the questions on a piece of paper. Okay? Then you can upload your completed mock paper, either as you can take a picture of it, you can scan it in, or if you've done it on a Word document, you can just upload the Word document. However you do it, just make sure that your answers are legible. If I can't read your answers, then I can't, mark your paper. So make sure it's legible, upload it to shobi.com using the same class code. If we could get submissions by Tuesday the 14th, that's Tuesday next week, that would be fantastic. And on Wednesday, we will have an online lesson going through the paper. Okay, if you've got any issues there, feel free to get in touch, d.devlin@hasler.org.uk. I hope you enjoy the paper. It's not too hard. There are questions you will all be able to attempt, the majority of the questions, but there will also be some challenging ones for those who want a bit more of a challenge. Thank you very much for sticking through with another online lesson. Looking forward to seeing you next week for our last ever online lesson. Okay, goodbye. Good luck with the mock. Looking forward to receiving your completed mocks. Yep, control.